So let's solve this question. Which of the following complex functions is or are analytic on the complex plane? Okay, so let's see. First of all, so we have z. First of all, we have z is equal to x plus jy, where x comma y are real numbers and j is equal to square root of minus 1, of course. Okay, so now let's see. If you verify the options, what are the options they have given you? A, f of z is equal to j times real part of z, of course, here. Okay, then it is given on the complex plane, complete complex plane. So this is j times real part of z is actually x. Okay, so clearly, and b, okay, so again if you take b for example, so b, f of z is equal to, first let us identify the functions, j into imaginary part of z actually, so imaginary part of z which is equal to y, of course, and c, f of z is equal to e power mod z, which is a real function, of course, root of x square plus y square. Okay, and d is f of z is equal to z square minus z. This is a polynomial function, of course. Okay, so one understanding that we can see from all these three is this do not satisfy Cauchy-Riemann equations on complete complex plane, or basically you can say do not satisfy the Cauchy-Riemann equations at all points, of course. Okay, but this satisfy the Cauchy-Riemann equations at all points on complex plane, of course. Okay, so you can understand them. So therefore f of z is equal to z square minus z is analytic. Clear? Because see, also one more important point, if Cauchy-Riemann equations are satisfied, then the function need not be analytic until the derivatives are continuous. Okay, but here in this case, if function is analytic, then ultimately Cauchy-Riemann equations has to be satisfied. If Cauchy-Riemann equations are not satisfied, then ultimately it's not analytic. But here you can ask me, because they are satisfying the Cauchy-Riemann equations, but still is the derivatives continuous? This is a polynomial function, so there is no issue with derivatives at any point. At all the points derivatives are continuous. So along with you can write here, and derivatives are continuous. Derivatives are continuous means dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y, all these are continuous actually. Okay, so these are the two important conditions for the function to be analytic. First of all, if the CI is not satisfied, then no question of analyticity, just delete the topic of analyticity from your job. Okay, so anyway, D is the only function which you have analyticness, whereas the rest three do not are not analytic basically. Thank you.